Math time!
Hello everyone, today we will talk about finding the trigonometric ratios of special angles.
Finding the trigonometric ratios of special angles.
Finding the trigonometric ratios of special angles. So when you say special angles, these are the 30 degrees, 45 degrees, 60 degrees, and 90 degrees. And let's start with the first theorem. Okay, it says here that in a 45, 45, 90 degrees right triangle, the hypotenuse is square root of 2 times as long as each leg. So if we're going to take a look with this illustration here, okay, we have here a triangle. We have 45 degrees, and here is the right angle. That is the 90 degrees angle. And let A be the legs. So in this case, here is our right angle. So therefore, the side opposite to that one, that would be our hypotenuse. So if that's the hypotenuse, then these two sides in here, these are your legs. So again, let A be the legs. So therefore, this side in here is our leg. And that is represented by A. And remember that these two legs here are congruent. Okay? Then we are asked here to find the value of the trigonometric ratios. So we have the sine, cosine, tangent, cosecant, secant, and cotangent. So we have here also the mnemonic device that we use in finding these values. The so, ka, towa, ko, sha, kao. Now, so going back to the theorem, it says here once again that the hypotenuse is square root of 2 times as long as each leg. So in that way, since that we know that these legs in here are A, we let that one as our A, meaning to say this hypotenuse here is square root of 2 times as long as each leg. So therefore, this would gonna be A square root of 2. Is that clear? So let's find it out now. The sine 45. So we're just the same. Either if you're going to use this angle here or this angle here, since they're just equal, meaning opposite sides of that one are just the same. Okay? So that's how it makes special. So let's start with sine 45. Using sine is equal to opposite over hypotenuse. So let's make use of this one. Okay, so sine 45 is equal to opposite. What is the opposite? That is A. So that is A over the hypotenuse. Okay, so that is H. So A over A square root of 2. Okay, so remember, as we divide, A divided by A square root of 2, so that becomes 1. So what is left is only 1 over square root of 2. And rationalize, multiply that one by square root of 2, square root of 2. Therefore, you would have then 1 times square root of 2. The answer is square root of 2 over, so multiply the 2 and 2 here. So 2 times 2, that is 4. Square root of 4, that gives us 2. So the answer is sine 45 is square root of 2 over 2. Is that clear? Now let's move on for the cosine 45. For cosine 45, you have adjacent over hypotenuse. So what is our adjacent since we're talking about this angle here? So that's A. So still you would have A over hypotenuse. So it seems that they're just the same. So A square root of 2. So again, A divided by A square root of 2, that gives us 1 over square root of 2. Is that clear? Then rationalize, multiply the whole fraction by square root of 2 over square root of 2. So therefore, what is 1 times square root of 2? That is square root of 2. all over by 2 times 2, that is 4. What is square root of 4? That is 2. So meaning to say, sine and cosine 45 are just equal in measure. Alright, what about tangent 45? So for tangent 45, we have opposite over adjacent. So this one, opposite, that is A, over the adjacent is A. So that is A over A. What is A divided by A? That is equal to 1. Okay. So meaning tangent 45 is equal to 1. Next, how about the cosecant 45? For cosecant 45, we have hypotenuse over opposite. So hypotenuse, that is A, square root of 2. So A square root of 2 over the opposite of that. That's A. So what is A square root of 2 divided by A? So that's 1. So meaning what is left is only square root of 2. So cosecant 45 is equal to square root of 2. Next, secant 45. That is hypotenuse over adjacent. So our hypotenuse here is A square root of 2. So you have A square root of 2 over, that is adjacent. So here, that's A. Same thing, A square root of 2 divided by A, that becomes 1. So what is left is square root of 2. Is that clear? Now, how about the cotangent 45? Okay, cotangent 45, that is adjacent over opposite. So what is the adjacent of 45 here? So that is A. So that is A over, what is the opposite? That's A. So what is A divided by A? That is equal to 1. So therefore, cotangent 45 is equal to 1. Again, going back it here, sine 45 is square root of 2 over 2. Cosine 45 is square root of 2 over 2. Tangent 45 is 1. Cosecant 45 is 2. And secant 45 is square root of 2. And cotangent 45 is equal to 1. Let's check that one in our calculator. Okay. So using your calculator, we have sine. Okay, let's start with sine. Okay, sine 45. Wait. 45. Okay, that is 0.707. And that is equivalent of... Okay, let's try this one. Square root of 2 divided by 2. Well, of course, they're just the same. So as we have sine 45, you have 0.707 and so on and so forth. Okay? So again, sine 45. They're just the same. Same thing when we have cosine 45. They're just the same as well. Okay? How about tangent 45? Tan 45. Okay, that's equal to 1. Next, we have cosecant. Okay, so cosecant 45. Okay, no more to find rather in our calculator. It's anyway, you have it there already. Okay? Alright, so let's now fill in our values in our trigonometric ratios of the angles table. So again, we have sine 45. So we have to fill in the values of this: sine, cosine, tangent, cosecant, secant, and cotangent. So as we said, 45, that is square root of 2 over 2. While cosine 45, that is still square root of 2 over 2. And for the tangent, that is equal to 1. And cosecant, we have square root of 2. While secant is square root of 2. And lastly, we have 1. Alright, so we have now our table of values. So let's move on in finding the values of the 30, 60, and 90. Alright? Moving on to the second theorem stating that in a 30, 60, 90 degrees right triangle, the hypotenuse is twice as long as the shorter leg. Again, the hypotenuse is twice as long as the shorter leg. And of course, the longer leg is square root of 3 times as the shorter leg. Okay, so if you're going to take a look with this illustration, we have here our 30, 60, 90 degrees right triangle. So let A be the shorter leg. So which one is our shorter leg? Well, of course, the opposite side that is shorter in degree measure, that would be our shorter leg. So since this is 30, this is 60, this is 90, 30 is shorter than 60 and 90, so therefore this side in here is our shorter leg. So let's say that is our A. Okay. So going back it here, the hypotenuse is twice as the shorter leg. So meaning to say, our hypotenuse is always opposite to the right angle. So therefore, this side in here is our hypotenuse. So that is twice as the shorter leg. So here is our shorter leg. So that becomes 2A. And lastly, the longer leg is square root of 3 times as the shorter leg. So we'll just add on square root of 3 to A here. So since this would be our longer leg, so square root of 3. Alright, next, find the values of the 6 trigonometric ratios. The sine, cosine, and tangent, cosecant, secant, and cotangent. Okay, so here are the following that we are asked to find. Okay, let's start with sine 30 in this illustration. So we have the mnemonic device, so, ka, towa, ko, sha, kaw. Okay, sine 30, that is equal to opposite over hypotenuse. So where is sine 30? So here is the 30 degrees. So therefore the opposite, that is A, over the hypotenuse. What is the hypotenuse? That is 2A. So 2A. Therefore, what is A divided by 2A? So A divided by A, that's 1. So 1 half. Alright. So that is 1 over 2. So when you say sine 30, that is equal to 1 half. Next, how about cosine 30? So 30. Here is the angle. That is adjacent over hypotenuse. So what is the adjacent one? So that is A square root of 3. So that is A square root of 3 over the hypotenuse, that is 2A. Okay, so A divided by A, that's 1. So what is left is square root of 3 over 2. Okay, let's move on for the tangent. Tangent 30. So 30, that is opposite, that's A, over adjacent. So A over the adjacent is A square root of 3. Okay, so A divided by A, that's 1. So what is left is 1 over square root of 3. But you're not going to stop it there. You have to rationalize that one first, since we have a radical sign in our denominator. So we have to rationalize, multiply that one by square root of 3 over square root of 3. So what is left is 1 times square root of 3, that is square root of 3 over 3 times 3, that's 9. What is square root of 9? That is 3. So what is left is square root of 3 over 3. Moving on to cosecant 30. Okay, hypotenuse over opposite. So what is the hypotenuse? That's 2A. So 2A over the opposite, that is A. Okay, what is A divided by A? That's 1. So the answer is only 2. Good. Next, secant 30. Okay, secant 30 is hypotenuse over adjacent. So that is hypotenuse is 2A and the adjacent is a square root of 3. So a divided by a, that's 1. What is left is 2 over the square root of 3. Then rationalize square root of 3 divided by square root of 3. So what is 2 times square root of 3? That is 2 square root of 3 over that is 3. So the answer is 2 square root of 3 over 3. And lastly, we have the cotangent 30 degrees. So for cotangent 30 degrees, you have adjacent. Okay, in this illustration, that is adjacent, that is a square root of 3 over the opposite, that's a. So the answer is only square root of 3. Again, sine 30 is 1/2. Cosine 30 is square root of 3 over 2. Tangent 30 is square root of 3 over 3. Cosecant 30 is 2. Secant 30 is 2 square root of 3 over 3. And cotangent 30 is square root of 3. Is that clear? Okay. So therefore, for our table, we may now write. Okay, so we have sine 30. So that is 1/2. Okay, that's 1/2. Then cosine 30 is square root of 3 over 2. And tangent 30 is square root of 3 over 3. Cosecant 30 is 2. Secant 30 is 2 square root of 3 over 3. And cotangent, that is only square root of 3. Let's move on to the degree, 60 degrees. Alright. So same illustration. Let us find out the measure of these trigonometric ratios. Okay, for 60. Sine 60. So we'll make use of this angle here. Same illustration, right? Okay, so sine 60, that is opposite over hypotenuse. So what is the opposite of 60? That is a square root of 3 over the hypotenuse. That's 2a. Okay, so divide a by a. So what is left is only square root of 3 over 2. Is that clear? Next, cosine 60, that is adjacent. So that's a. And the hypotenuse is 2a. So a over 2a. So a divided by a, that's 1. So that is 1/2. Clear? Next, moving on to tangent 60. Opposite, that is a square root of 3 over the adjacent. So that's a. So the answer is only square root of 3. Next, cosecant 60 rather. That is hypotenuse 2a. Okay. Over the opposite. So that's a square root of 3. So a og a, we have 2 over square root of 3. Rationalize. We have square root of 3 over square root of 3. So the answer is 2 square root of 3 over 3. So 3 times 3, 9. Square root of 9 is 3. Next, for the second. So second hypotenuse, that is 2a over the adjacent, that's a. So the answer is only 2. Clear? Next, last one. We have cotangent 60. That is adjacent is a over the opposite is a square root of 3. So again, that is 1 over square root of 3. Rationalize. We have square root of 3. So that is square root of 3 over 3. Okay. So writing it on our table of values, you have then, okay, so sine 60. That is square root of 3 over 2. And cosine 60, that is 1/2. And we have tangent 60, square root of 3. Next, we have cosecant 60. That is 2 square root of 3 over 3. And we have second 60. That is 2. And lastly, we have square root of 3 over 3. Is that clear? Okay, again, so we have here our measures or values of the 6 trigonometric ratios for the 30 degrees, and here is the 60 degrees. And we have also here the 45 degrees. Okay.